Okay, now I want to look at problem 37.3, page 59 of volume 5. Okay, and in this and in this problem, there's going to be a punk, not drawn to scale, a mini punk in frame S. Frame S is at rest, and this rod has a length of 2 centimeters in this frame. And in this frame, that rod is also at rest. So the punk and the rod are both at rest when viewed in frame S. There's an astronaut over here, right? You can think of this astronaut as flying away here. So if the astronaut was seen in this frame, here's the astronaut. We'll just call this the letter A. The astronaut will be going this way with speed beta. Now remember when I say beta, right? It doesn't look like a speed because it has no units, but that's essentially 55.5% of light speed. So it's essentially a speed, 0.555 c. All right. So, okay. And what I'm curious about is in this frame, the astronaut would be flying that way. Well, in the astronaut's frame that's moving at the same rate as the astronaut would be at rest. What would the rod look like? That's our question. Okay, so, and now to get there, let's do all these steps. First, what is the speed in meters per second? Let's just do that, right? What is it? 2.99, I want to get the, is it 997? 998. E8, so that's the speed of light. Well, let me just write this so you know what I'm doing. V equals beta C, because beta equals V over C. That's how it's defined. So it's 0.555 C. C is this number you can look up. So times 0.555. I get, let's see, 1, 2, 3, 4, 5, 6. Oh, let's just do this in scientific notation, okay? Scientific mode. Answer 1.6639 times 10 to the 8th meters per second. About half light speed, right? Light speed's about 3 times 10 to the 8th. This is about 1.5 times 10 to the 8th. That looks good. Okay, who will measure the proper length? I think you should pause the video and try and do this yourself. I'll discuss it in a minute. 1, 2, 3. Here we go. Who measures the proper length? If we can't identify the proper length, we're going to screw this up when we try to plug in the time dilation formula, or sorry, the length contraction formula. So in this case, the observer who is at rest relative to the object records the proper length. So I would say the punk in frame was, in this problem, let's see, I called that frame S, okay? So notice you got to look carefully in each example. Okay, it's not always that S is the moving frame. A lot of times the unprimed frame is the at-rest frame and the primed frame is the moving frame. But you'll notice in the last problem, I think I had the primed frame in black and it was over here, and the unprimed frame was over here in purple or something. So just, yeah, watch out, always pay attention. And in this case, frame S is at rest relative to the rod. That measures the proper length. Great. So what is the length observed by the astronaut? Here's how I remember it. There's the words length contraction. That means anybody else measures a shorter length. So I'm going to think there's the length. I'll call this one length prime, which is the length in front S, and that's going to be related to L in, this is in frame S, and this is in frame S prime. Now, they're going to be related, and I either need to put a gamma here or a gamma here, something like that. Or you could say I need to, right, where do I put gamma is the question. Well, let's think. This one, the proper length is right here. So I'm going to mention in this case, this is the proper length, okay? I don't want you to blindly assume S will always give you the proper length, okay? You got to read and think about that step. That is critical. Determining the proper length, just remember the phrasing. The object is at rest relative to that frame. Okay, so now I know length should get smaller. I also know, think, gamma is greater than 1, so I better divide by gamma on this side or multiply by gamma on that side. Let me think. The frame S prime should be shorter because gamma is bigger than 1. The proper length is the longest length. The proper time is the shortest time. That's how you keep those straight. Proper length, longest length. Length contraction. Proper time, shortest time. Times get dilated in other frames. They get bigger. Okay, so now at this point, I think all we need to do is get gamma, and we're off to our races. So we can get this, the length observed by the astronaut. So gamma is 1 over the square root of 1 minus 0.555 squared. I'm going to get that really quick. 1 minus 0.555 x squared. Oh, I'm in scientific mode. Let's get out of that. Okay, and then I'm going to do 1 divided by square root of the answer. 1.202. If you want to keep an extra digit, it's a 1. And so now I should be able to get L prime. It's just the original length, 2 centimeters, the proper length divided by that. So I'll take 2 and divide by answer, 1.664. Because this one was 2.00 centimeters. I guess I better put my units on there. And gamma was, there we go. So what would that look like? If I tried to draw this to scale, so over here, 20 centimeters corresponds to 2. So over here, it'd be about, oops, 16. So in this frame, the distance is 1.664 centimeters. Great. And oh, that's kind of a weird coincidence that this one rounds to 1.664. It's kind of interesting, huh? Just kind of random. Anyways, in this case, which way is the rod moving in that frame? Well, let's think. The astronaut moves to the right relative to the rod. That means the rod is actually flying this way. So you'd think about the rod flying this way, right? At some speed, beta. So this is what's kind of weird about this. In this frame, the rod's at rest, the astronaut's flying that way. In this frame, the astronaut's at rest and the rod is flying this way. All right. And now there's one more question here, I think, isn't there? Oh, yeah, somewhere. Oh, whoops. I think this was part E. I accidentally just did part E. Sorry about that. Part D is who registers a larger height of the rod? If you want to pause the video and think, which observer, the punk at rest in this frame or the astronaut at rest in the moving frame, which one will measure a larger height of the rod? 3, 2, 1. Same. The length contraction will only happen in the direction you're moving. So, right, we see a contraction in the direction you're moving, but not in the other dimensions, into and out of the page or up and down. So they both have the same height. It's just the length that gets contracted. All right? And there's a classic problem that you should probably follow this up with. If you look at 37.5, you should definitely do that one. I'll just go over here to kind of sketch it out for you. So I'll just mention, do 37.5 next. And so this is a classic problem where the rod is at an angle. And when this happens, right? When you have this situation, a similar type problem, what will happen is this dimension will shrink, but the height won't. And so that changes the angle. And so you can practice this problem in 37.5 next, all right? Let's go ahead and leave that.